Salam and welcome everyone. So today we're going to be working on the question on the screen from chapter 5 of the Atkins Physical Chemistry 11th edition. As you can see, this is from exercise 3A. So the question says, suppose that n sub A is equal to 0.10 n sub B and a small change in composition results in mu sub A changing by change in mu sub A equals plus 12 joule per mole. By how much will mu sub B change? Now, I want to quickly mention this that n sub A is just basically the number of moles of component A, and then n sub B is the number of moles of component B in the mixture. And they also said and a small change in composition results in mu sub A is the same thing as chemical potential of component A. And then this here is just saying the change in chemical potential of component A. And then mu sub B is a change in chemical potential of component B. Suppose that n sub A is equal to 0.10 n sub B and a small change in composition results in the change in chemical potential of A changing by plus 12 joule per mole. By how much will the change in chemical potential of B change? So that's basically what this is asking you. So whenever you see a question like this where you're given the number of moles of A, okay, which is just 0.10 n sub B, and you're also given the chemical potential. So for example, the chemical potential of A is equal to the change in chemical potential of A. So it's just there's this delta sign, or you can just say change in chemical potential of A. So basically, change in chemical potential of A, let's stick to what they wrote. So change in chemical potential of A is just plus 12 joule per mole. So now we're being asked that what is going to be the change in chemical potential of B. Now, in simple mixtures, anytime you have a question where you're given the number of moles and you have the change in chemical potential, note that you're going to be using the Gibbs-Duhem equation. So the Gibbs-Duhem equation, okay, again, this is in chapter 5 of your Atkins Physical Chemistry 11th edition textbook. So the Gibbs-Duhem or Duhem equation, okay, is an equation that basically explains that the sum of the multiplication or the sum of the product of the number of moles of each component multiplied by the change in chemical potential of that component is equal to 0. So that is what it's just telling us. So the sum, where J is like the components or the group of components. So rewriting this, let's say we're dealing with a binary mixture. For those of you who don't know what binary mixture is, it's just mixture between two components, okay? Mixture between two components, right? Just like mixture between water and sugar. That's a mixture. Sugar water is a mixture between two components, sugar and water. So mixture between two components, okay, that's a binary mixture. Sugar water is a binary mixture, salt water is a binary mixture, just salt and water. So now that we understand the binary mixture between two components, let me explain this with the new equation I just talked about, the Gibbs-Duhem equation. So basically what this equation is saying is G, or the change in G, is equal to, where G means Gibbs energy, is equal to the number of moles of A multiplied by the change in chemical potential of A plus the number of moles of B multiplied by the change in chemical potential of B equals 0, because at constant temperature and pressure, the Gibbs energy is 0, equals 0. And now I'm going to be wondering, okay, how do we know that this is a constant temperature and pressure question? Well, we're going to assume that that's what's going on in the mixture, because they did not tell us that the temperature changes or the pressure changes. So since the pressure remains the same and the temperature remains the same in this mixture, what's just going to happen is that the Gibbs energy is going to equal, or the change in Gibbs energy is going to be equal to 0. So basically, there is no change in Gibbs energy. So yeah. So now, knowing all of this that I have said, this is the Gibbs-Duhem equation that we're going to be using right here. We are going to be substituting all our values into this equation. So remember, n sub A is 0.10 n sub B, okay? The change in the chemical potential of A is equal to plus 12 joule per mole. And the change in chemical potential of B is just simply what we're looking for. So now we have this equation right here, and we can just simply substitute. So you have N sub A, change in chemical potential of A, plus N sub B, and the change in chemical potential of B equals 0. So when we substitute, we end up with 0.10 N sub B, okay, multiplied by 12, plus 12, by the way, joule per mole, okay, plus N sub B multiplied by the change in chemical potential of B, okay, equal to 0. So that's basically what's going on here. So the next thing we have to do is just do the multiplication. So 0.10 NB times 12 joule per mole is just simply going to be 1.2, okay, NB joule per mole. And then you have this information here. And of course, you put it in the right side of the equation. So you have negative NB change in chemical potential of B. So that's basically what that would be. Of course, we divide both sides of the equation, okay, by NB because we're trying to determine the change in chemical potential of B. So we must divide both sides by NB, the number of moles of B. So when we do that, we cancel out NB on the right side and negative NB, on the right side, and also negative NB on the left side. So we cancel this out as well. So now the change in chemical potential of B, okay, or you can just say D of B, is going to equal negative 1.2 joule per mole. So that's basically the answer to this question. So therefore, the change in chemical potential of B is going to change by 1.2 joule per mole negative, or is going to decrease by 1.2 joule per mole. So basically, changing chemical potential is negative 1.2 joule per mole. Of course, we don't have a negative value. Really, when you're dealing with change, what you're just saying is that it's going to decrease by 1.2 joule per mole. If you have any questions, please put it in the comment section. If you're a student struggling in any of your STEM related courses, whether you're in middle school, high school, university, or college, and you also want to excel in your academic career, make sure you email me at shohabitutoring@gmail.com. I help students be the best version of themselves in academia as a student and as an aspiring future scientist. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.